Hi guys, welcome back. Good job on those videos the other day. I enjoyed them. Some of them had some funny comments in them. Most of them were well done. If you made a small mistake and didn't get full credit, you can still resubmit those. So just resubmit them and then I will regrade them. We are going to do 2 more videos today in addition to watching this short video. So today we're going to start this video on page 421. We're building off these rational functions we started about a week and a half ago. And we're actually going to build off of the example we started a week and a half ago with those kids going to summer camp. So this is on page 421. Take out your iPad, take out your hard copy of the book, and find number 1 with me. Let's read it together. It says, the finance committee from the nonprofit summer camp in lesson 27-1 decides to award 30 scholarships to students who otherwise could not afford the camp. These scholarships include full use of the facilities and all meals at no charge. Okay, so it wants us to come up with this table to determine what to charge each student. If you look back at 27-1, the fixed costs for this camp were $12,000, and the cost of the meals for each student were $45, and we did that times the number of students. Okay, so for this first, let's look at this first row, 50 students. If I take that 50 and plug it into x for 12,000 plus 45x, I'll get $14,250. That is the fixed cost plus the cost of meals. This next column is where it gets a little different. There are 50 campers going, but 30 of them are on scholarship, meaning that only 20 now are paying. On your calculator, if you do 14,250 divided by the 20 paying campers, you get $712.50. All right. So let's do one more column here. Let's do one more row. Let's do 75 students. I plug 75 in for x. I get 15,375. There's not 75 paying campers though. There's only 45 paying campers. If I divide those two numbers, I get 341.67. Okay, so what I want you to pause the video here and take about a minute or two to try to finish this table. Really focus on these last 3 spots. Just like we did in the 27-1 lesson, we want to come up with things with X on that last row. So pause the video with your calculator, try to fill in the rest of this table, and really think about that last row. Okay, here's what you should have had. Keep following the pattern down. The number of paying customers, fixed cost, dividing them. This is what we talked about earlier, but look what's happening here with the number of paying customers. You're just taking the number of campers and subtracting the 30 scholarships, which gives us a expression that looks like that. So you can see this is what's creating those rational functions we've been dealing with, and they can get more and more complicated. The more restrictions, the more different things you add on, the more and more complicated these rational functions can get. All right, let's take a second using that table, and let's plot a few points. I've given you the scale that I want to go by here, so we're all on the same page. I'm just going by 50s. And if we plot a few of these points, so the first value we had, number of campers were 50. The fee per paying camper was $712.50. So if I go by 50, $712 is right up here approximately, as close as we can get. The next value we had was 75 paying customers. The fee per paying camper there was $341. So 75, 341 would be right about there, right? Best approximation. Next value, 100 campers was 235. So 100 campers, 235, right about there. Let's skip to 500. If we go 500, it would be $73 per camper. And 1,000, we're right above 58. So right above there. So you can see we still get that same shape that we had in the last section, right? It's kind of like an exponential decay, a little different though, but it's got that swooping curve. I'm not connecting these points because we'll talk about that in a second when we do the domain and range. The algebraic model here is that thing we came up with in the last row, that expression. So it's 12,000 plus 45x all over x minus 30. And I like this question here, talking about what the numerator and denominator stand for. The numerator is the total fixed costs plus meals. Total fixed cost plus meals. And the denominator is the number of paying campers. So not the number of campers anymore, just the number of campers that actually pay. All right. So check this out. Number 4 says, how does the graph in item 1b compare to the one in item 7c in the previous lesson? Didn't expect you guys to remember that graph, so I copied and pasted it down here. This is the graph we did about a week and a half ago, and this is the function we came up with. So you can see the numerator is the same. The denominator is slightly different. If I compare this graph, the new one I came up with this one we had last week, you can see that both graphs are decreasing. So let's write that both graphs decrease. And both graphs approach a y value of 45. Okay, right? We're talking about that y value of 45. Even if a ton of kids go, they're still going to have to pay a little bit. They're each going to have to pay $45 for the food and then a little bit for the camp. The more people go, the less the smaller above 45 we have to pay. Here's the difference though. Look at this new graph. That denominator x minus 30 means that the new graph all we care about are the x values greater than 30. That's the difference. In this graph down here in 7c, that if you look back at the domain, that x could be anything greater than 0. We already said it had to be integers, but 1 worked, 2 worked, 3 worked, etc. In our new graph, because of this new denominator being x minus 30, we can't have any numbers less than 30. Technically, now in the math world we can, but in the context of this problem, that wouldn't make sense. If you have less than 30, then everybody would be on scholarship and you wouldn't have anybody paying. So it's impossible. All right. So that's the difference between the old graph and now putting that the new graph where we have that x minus 30 in the denominator. Okay. So let's try this a little bit. Check out number 7 and number 8. These are good problems using the new graph, the one with the x minus 30 in the denominator. So pause the video here and try to answer 7 and 8. Okay, so number 7 wanted you to plug in 25 for x into that expression we came up with, that function we came up with, I should say. And if you do that, f of 25 is negative 2,625. And so what this shows us, and we kind of talked about this already, is that this function this shows that f of x is not valid for numbers less than 30. Right? 30 scholarships, we need at least 30 kids to go to be paying, or actually at least one to be paying for this camp to actually run. Let's talk about the domain. Domain is very similar to what was in the last section we did, 27-1. Where instead of starting at 0 now, we're going to start at 30 and go to infinity. But we have to add integers only. That's why on our graph we did not connect those points. If we connected them, we would have said that any decimal fraction is included on the graph. We only wanted integers. The range, a little bit different. Remember, the range comes from the domain. Right, so let's go through the scenarios. If a bunch of campers pay, if there's millions of campers, and remember, there are some restrictions in this camp, we just don't know what it is. We don't know how many kids can go, we don't know how many kids, what the maximum capacity is. But imagine that many kids were allowed to go. If X was a very large number, right, many campers, then the average cost per camper, or the cost per camper would be around $45. Now, we're not using a bracket there because it will never equal 45, but the campers will at least have to pay for their food and then a little bit more if there's a lot of campers. Okay? Now, worst case scenario, not realistic, but possible, what if only 31 campers go? Right? So if 31 campers go, that means there's 30 scholarships. That'd be mean only one paying. If that happens, then that poor kid would pay $13,395. Not realistic, but possible. That'd be one paying camper, so it's the maximum of the range. Many campers, the $45, so you have to pay for their meals, and then a little extra based on how many kids go. So that's the domain and range of our new function. The big thing to notice here is the domain. Now, because of that x minus 30 in the denominator, we can't be less than 30. Now, there are x values we can plug in less than 30, but in the context of this problem, we have to start at 30 going to the right forever. All right. Well, I hope that made sense. Again, email me with any questions. The homework's going to be very similar to the problems we did here. It's posted on Schoology. It's called 27-2 homework. This will be the last distance learning day before spring break, so have a great spring break. If you're going anywhere, stay safe, wash your hands, and I will see you guys when we get back.